It's a soil water storage update. Now, just to sort of make the point at the outset that the change in the statutory instrument regarding nitrates regulations of last year, now that's in control of the Department of Housing, Local Government and Heritage. Many people might think that that'll be under the Department of Agriculture, but it's not. It's under this department, which is that's where the legislation comes from. Okay, so we go on to the next slide. Right. So what's the current situation, or what's the situation just before the changes are taking place this year? So just defining what soil water is. So there's a kind of a scientific definition there. So we're talking about a BOD level, the amount of oxygen needed to consume to use up the soil water. So less than 2,500 and less than 1% dry matter. So soil water occurs from a number of locations. So we have runoff from dungsteads, farmyard manure where it's stored, and silage pits. So they're all classed as soil water. Now, in most cases, they're stored with the slurry. When the volumes are calculated and when they're joined up with slurry, then they're counted as slurry for storage purposes. So what we're dealing mainly with tonight is what's coming from milking yard collecting yards and milking parlour areas. So in most of those cases, the parlour washings they're stored separately, but sometimes they're mixed with the slurry. So there's kind of two situations that we want to look at there. So previously, up to now, what was demanded was 10-day storage requirement and 15 days storage for soil water if it was built since 2015. Now, up to the end of last year, you can spread soil water anytime, and it can be spread with the splash plate, and you can still spread with the splash plate. But the ability to spread soil water at any stage of the year sort of finished up at the end of last year. We're into the new regime as of 2023. Now, the main contributor, what drives volume in soil water in the milking situation is the wash water associated with bulk tanks and parlour washings. And we're using a figure there of about 30 litres per day per cow. And we're talking about what's coming from the collecting yard area. So it's the rain that's falling on that. So we have two different figures here for 23 millimetres a week in Kilkenny and 31 millimetres in Waterford. So that volume of water has to be calculated as well when we're talking about storage. So that's the background to soil water as we're looking at it this evening. Right, so it's kind of just a few general restrictions that are there on application of soil water. Upward facing splash plate is not allowed, has to be going down onto the ground. No application from farm roadways. In recent with the kind of ground conditions we've had of late, there may be a temptation there to spread it off of farm roadways, so that's not permitted. And you must allow for the weather conditions. So we have poor weather conditions such as waterlogged fields, ground that's prone to flooding. If it was covered in snow, ground with a severe slope, and if there was heavy rain forecast in 48 hours, spreading soil water shouldn't happen. There are some people that will be using irrigation systems, and there's a rate there which they cannot exceed. There will be a small number of cases of that happening. So that's just general restrictions on the application of soil water. So the next thing we move on to then is what are the changes that have occurred this year? So 2023, you're expected to have 3 weeks storage, and we can spread soil water from the 10th to the 31st of December. So that's coming up fairly soon. Now next year, then we get to the full level of limits that's going to be imposed. So it can spread soil water in the month of December. So 1 month storage required. So that's if you're storing it separately. You need to have 1 month storage in place for it. And for the winter milk producers, they get until 2025 to get to the stage of having 1 month's soil water storage. So that's what with Pat Moylan shortly, after I've gone through this, we'll give a rundown there on how the calculations are done regarding the 31 days, the 1 month storage versus the situation where it's stored with the slurry. Now the big difference there, if the soil water is stored with the slurry, then you have to start counting what's produced from the 1st of October, which is the start of the closed period. Now this year, you may remember the closed period for spreading slurry was to go back to the 1st of October, had been the 15th of October 2 years ago, 8th of October last year. Now there was an extension back to the 15th of October because of the poor weather conditions this year, but the starting point for the future is this 1st of October. So if the soil water and if the parlour washings and so on are mixed with the slurry, we have to calculate what's produced from the 1st of October right through to the drying off date. So that could be sometime end of November into December, whatever the length is. And again, Pat will go through that. So that puts a serious increase on the volume of storage that's required. It'll more than double what you need compared to if you had a separate soil water tank. Now, we need to bear in mind too that at present, the storage figures that we're using for storing slurry and for storing soil water are being reviewed. There's a possibility, a potential that these figures could increase in the future. So I suppose the underlying thought would be that if you're going to do anything with regard to increasing overall storage on the farm and to try and future-proof it, you need to be thinking maybe of a greater amount of storage than is actually demanded at the moment, because the figures just could be recalculated in the future. Okay, now just to go to a slightly different angle looking on it, Deirdre Lynn is here with us, and Deirdre was working with the ASAP program, which is a national program jointly run by Teagasc, the co-ops and the county council to improve water quality. So I suppose at this stage we all know that the whole issue of the derogation continuing and any changes that are going to take place are all hinge on improving water quality. So hence the ASAP program, which Deirdre will explain shortly. So locally here, we look at the water quality here in Kilkenny, where Deirdre is working. In Waterford, we have Cathal Summers on a similar role down there, working with Teagasc in that role. So she'll also go through the river catchments at the moment that are being inspected and other activities that she's engaged in, and where this is going to go to in the future. Right, just two other angles just to mention here, that if you're thinking of building a tank like that, there might be some things that it might influence your decision. Just to say, we have the accelerated depreciation option which was introduced in a budget some time ago. So you can do a 50% write-off over 2 years of any investments carried out between the 1st of January 23 and the 31st of December 2025. So that option is there for people who might consider making advantage of that. You also have the possibility of getting, if you want to go for a TAMS grant for any tanks that you want to do, but in all cases, pretty well all cases, planning permission is required, and you need to show that you have adequate storage for 16 weeks on your farm. Now you can take into account loose houses that you have on the farm to get those calculations in order, but there's a time factor involved in that. There's an expense as well, but the time factor is the big thing to get this planning permission in place. So it's something you have to work on in advance of going for the grants. So that's just the introduction to the whole soil water concept. So at this stage, I think Mark, you want to hand over to Pat Moylan, and Pat's going to do a few calculations for us to show where the figures are coming from and how it might work out in practice on farms.
What I'm going to do here in just one moment here is just bring you through a case study for a farmer client of mine, and look at the differences where slurry is stored with soil water and where the soil water is stored on its own. So just as you see here on the next slide, this is the current situation on the farm. You can see the drawing there. It's a typical 100 cow herd, 16 unit milking parlour, including a dairy. So as you can see there, the question to the left hand side there is, what is the tank size for this particular investment? And what I've highlighted there are the yards that all drain from right to left with the slope in the concrete into that tank. So they obviously, as we'll see in a moment, have an influence on the size of that tank. So you have a 16 unit parlour, exit into a holding yard where there's a crush. And I suppose nowadays we see a lot of drafting units being installed with a slurry channel linked to the tank at the back of the milking parlour. And that tank there straddles both the return yard and the collection yard. And I've all the key dimensions put in there. But look, that would be the first step in the calculation, is to measure up all the yards that drain in towards the tank. And on farm visits, I suppose, around the country, the biggest issue on farm yards, especially dairy farms, is the volume or the size of yards that are draining into a tank area. And they are having a huge effect on filling that tank, obviously, when it rains. So I suppose the first thing we could say as a tip to try and reduce soil water storage requirements on farm is, how can you minimise the dirty yard area used by the cows in connection at milking time? Can they be rerouted a different way? Can the concrete areas being reduced? Is there, is there a lot of loafing area, surplus area that could be tightened up? So that's just the case study. If you can visualize that's what it is. And I suppose what we're going to move on to next is a little calculator we've put together here that we can do for any of our clients here. And we're going to work out two things. What are the requirements for this farm? If A, stored with slurry, or B, stored separately. So I'll move on to the calculator. I'm just going to change screens here again. Just 1 second there. Hopefully you visualize what we said there. So look, this is just a little calculator here. I'll just bring you this simple Excel thing, which you can access through your advisor. So the first scenario for this farm here, we're going to calculate what storage is required where it is stored with slurry. So first of all, I'll just simply calculate the slurry storage requirement as things currently stand. So 100 cows, the current requirement is 0.33 of a cubic meter per cow per week, which is not short off of 70 gallons, a cubic meter being 220 gallons. And currently in zone A, where we are in Kilkenny watered area, we are required to have 16 weeks slurry storage. And you see there before I look at soil water, that calculates at 528 cubic meters, which is well over 110,000 gallons. So approximately in gallons, for people out there, the figure is currently 1,160 gallons, but as Michael said, that is subject to change. And as a guesstimate or an estimate, I would say be at least buffering an additional 20 to 25% on top of that for future requirements. So if we move down now, I suppose, to the second part of the calculator here, we want to work out here what's happening here as regards the collection or the production of soil water. So from the drawing that we looked at a few moments ago, I'll just put in the dimensions in meters of the collection yard. It's 21 meters by 6.5. That's just the area of it. We have the holding yard where the cows come out of first of all from the paddock where the drafter is located. It's 19.2 by 20 foot wide, which is 6.05. And then we have the return yard. So all those areas are draining back towards the tank. I suppose the next thing we're coming at here is what's happening here as regards the number of weeks. I suppose this is the crucial thing, as Michael has touched on already. So because we're storing it with slurry, we have to cater for the period from the 1st of October to when the cows are drying off. So in this example here, the farmer tells me that he plans to have everything dried off by the 15th of December. So when you work out the number of weeks from the 1st of October to the 15th of December, you're getting approximately 11 weeks. So what's happening here, when I just move off the screen here, you'll see the amount of rainfall calculated. So it's the length by the breadth in meters, multiplied by the rainfall for Kilkenny, which is there at 0.023 cubic meters per square meter of yard area. And I believe the figure is 0.031 cubic meters per square meter for County Waterford. So that's the 23 mil and the 31 mil converted into cubic meters per square meter of the yard area. So we have the same thing for all 3 yards, 11 weeks. And we're assuming after the end of the 11 weeks that those yards are scraped clean for the last time, and that yard water then is clean water and can be diverted to the clean water drains around the farmyard. So as you can see here, before I look at what's coming from the milking parlour, we now have a figure there of 96 cubic meters, which is 21,135 gallons coming from the yards alone over that 11-week period. So obviously you can see the longer you milk into the winter, and indeed if you're milking over through the full winter, you'll be looking at 16-week storage. And obviously the size of the area of the yard has a huge influence on the quantity of water that you must store. It's all in this example now being stored with slurry, so it's total storage. And the last thing then, I suppose, is it's a 100 cow herd. So, really whether this is to cater for the bull tank and the milk machine. So whether there's 100 cows we milked or 80 cows milked, the figure is going to be the same. So it's based on the maximum number of cows at peak. It's 100 cows. Where's the 0.21 cubic meters per cow per week coming from? That's the 30 litres per cow per day that Michael mentioned, which is currently under review. And depending on your milking system, whether it be robotic, rotary, etc., that figure could be much higher. So again, this is the current figure, 30 litres per cow per day to cater what's coming from the milking parlour, the bull tank washing, etc. And again, in this case here, we're milking for 11 weeks during the closed period. So as you can see here, the figure in the green here is telling us the soil water being produced during the period. So it's quite substantial there, 327 cubic meters, which is just 72,000 gallons of water. And that water is being added to the slurry produced. And the slurry produced for this cow herd is above the 528. So you can see then what the total is here on the right hand side. A total storage requirement of 855 cubic meters. So that's just a little simple Excel calculator, and all you need to have for your advisor is the key dimensions and how long you intend milking into the close period. So we'll contrast that now, moving on down the page, and if there's any questions we can ask, well, just a simple Excel thing for the purpose of tonight's exercise. So now we're going to deal with a scenario where the soil water tank is separate to slurry storage. So as Michael alluded to, going forward next year, this year it's 3 weeks soil water storage is required. But going forward, it's going to be the full month of December. So that in weeks is actually 4.4 weeks. So again, we have the same thing here. We have the rainfall coming off the dirt yards for the month of December. So instead of putting in 11 weeks, I'm putting in the 4.4. And that's the soil water coming off the yards during that month of December. And then the dairy washings during the same close period of 4.4 weeks. So again, you know, I'm assuming just here now, for example, maybe we can reduce the cow number back by to allow for the fact that maybe all the cows are not going to milk for the full 4.4 weeks December. But I think, a bit like nobody has yet told me that a bulk tank that was too big. I think we should over-calculate this figure, not to under-calculate it. So I suppose what you can see here now is that the total soil water produced in this calculation is 131 cubic meters. And you can compare and contrast that with the figure above of 327. So there's a huge difference there. And I suppose that's what we want to make people aware of tonight. The consequences if you are storing soiled water with slurry. There's a huge difference. So basically my figure at the bottom here is 40% of the figure above. So really, I suppose if we were back then to finish off this conversation here, we are with the second scenario here where you're building a tank here to store the soil water separately. Well, what does a tank of 28,000 gallons look like? So if I make the tank standard of 8 foot deep and I pick a 14-foot 6 flat, which is 4.41 meters, well, just to come up with the length then, I just take the quantity, 131, divided by. So a nice round figure I just put in for a minute. So you basically can see that if we had to build construct a tank on the aforementioned drawing there, it would have to be 18 meters long, which is close to 55, 56 feet, a 14-foot 6 flat, and 8 foot deep. And the reason that the capacity here is maybe a little less than if you take out your calculator, what I've done there, is that the depth here, while it is a gross depth of 8 foot, 2.44 meters, you have to allow for the freeboard and rainfall on an uncovered tank. So in reality, the net depth of that tank is actually 1.74 meters. So there's a tank now. If someone asked you in the morning, or if someone's trying to solve our problem there, we need a tank practically 18 meters long by a 14-foot 6 flat, for example, and 8 foot deep to suffice to meet the minimum requirement on that farm of 131 cubic meters. And I suppose just to make the point too, don't forget that the bigger that you make the soil water tank, the less frequently you will have to empty it during even the summer period. And I suppose, Michael, the other question that comes up to mind is, when is a tank not a soil water tank? If animals are fed on a collection yard tank, you know, whether it be buffer feeding or during the winter period, it is no longer a soil water tank, it is a slurry tank, and you must abide by the closed period. And the actual analysis, the chemical analysis, is that the dry matter of the soil water has to be below 1% for it to be soiled water. So just something to alert you to be careful on. So in summary, unless there's any question, that just as an Excel calculator that all the Teagasc advisors have in the two counties, and we can do the figures for your own farm, looking at total storage, where you're going to have all animal types included here, along with calculating and giving you the best guidance as we can on the current figures. But as I said at the outset, I think I'll be adding on 20-25% to those measurements, and that's what the resultant figure is. 327 for 100 cow herds, 327 cubic meters. We're milking to the 15th December versus 131, and that's a difference of 60% between the top and the bottom figures. So without further ado, that's what I want to add to the conversation tonight, and we'll take questions later. So
Thanks, Pat. Yeah, I suppose that just getting the big picture out of the whole thing there. Yes, Pat, from the calculations Pat has done there, you can just see the difference in the figures that depending on which way you approach it. So if it's one of the things that we want you just to take away from this evening is that message, and that to apply it to your own farm. So there is room there to put in questions there on the Q&A session, the Q&A box at the bottom, and we'll come back to them at the end. So that's so. Thanks for that, Pat. We'll be back to you afterwards. So now I'm going to introduce Deirdre Glynn. Deirdre's, as it would be familiar to many of you here in Kilkenny, and Cathal Summers, her counterpart to some of you in Waterford. So I'm going to introduce Deirdre there. Okay, thanks, Deirdre.
Good evening, everybody. I'm Deirdre Glynn. I hope you're all well tonight, and I'm working on the ASAP programme in Kilkenny. So the ASAP programme is the Agricultural Sustainability Support and Advisory Programme. So it's quite the mouthful, but basically I'm working on water quality in Kilkenny. So myself and Cathal Summers, who's based in Waterford, we work collaboratively with the cooperatives to provide a free and confidential service to farmers. So this service is also underpinned by science, okay, and data, which is provided by our local area's water programme team, okay. So I suppose collaboration and teamwork are at the core of what we do. And when I mention teamwork, I'm mentioning very strongly farmers in this scenario as well. So I'm working in what are called selected priority areas for action, or catchments in Kilkenny, and our goal is to achieve good water quality status by 2027. Now, improvements have been made in some areas, but we do need to build on this going forward and gain more momentum going forward. So we work on the science, or the referrals that are given to us by the science done by the Law Pro scientists. So when agriculture is the pressure in a specific catchment, we work and engage with the farmers within these catchments to put actions in place, and these have to be achievable actions for the farmer to remediate the pressure. So these referrals would then culminate in us giving a service to the farmer. So what do we look at in general? So we look at nutrient management planning on the farm, so targeted use of slurry and fertilizer. We look at land management on the farm. We look at critical source areas, and we also look at farmyard management. So we can go on to the next slide, please, Mark. So these areas for action. So we've been working on the ground since 2019 and some of the catchments, and 2021 there in the Brega catchment. So what have we achieved so far in Kilkenny? And we've also achieved good work also in Waterford, which Cathal will be able to tell you if you get in contact with him. So in the Brega 20, up until from 2010 to 2015, it was unassigned, which means that there wasn't an awful lot of data or science on it, or a huge amount of monitoring. So we don't have a lot there for that. But from 18 to 21, it's at moderate. Now we're trying to achieve good. So a little bit of work to do there. In the Dreelingstown, so that's around the Dreelingstown area, it's at moderate status as well. So we're trying to get that up to good. So the pressures within the Brega and the Dreelingstown are a mixture of nitrate and phosphate in different areas, depending on the soil type. So if it's a heavy clay soil, you're looking at phosphate being more of a pressure. Okay, and then the sandy, loamy soils, nitrate is more of a pressure because nitrate moves downwards. So in the Brega 20 then, we have, so that's out the Callan Road, Palmerstown, Kilcreen area, moderate. Dreelingstown, moderate. Brigade 10 then is Coorstown, Ballyfront direction. So that's gone from moderate to poor. Now there is heavy clay soils out in that general direction. So phosphate might be the biggest issue there. So, you know, with tillage, drinking point accesses, that kind of thing. So we're working with the farmers to try and remediate that. The Brigade 30 then is in around the town. It was at poor and it's gone to moderate. So that's around Dunningstown, from the city out to Dunningstown. So they've put in improvements to the wastewater treatment plant in the area. So that's where we see that improvement. The Dinan South then, so that's from Coon on down to Ravenna. It's gone from moderate to good. That's an improvement. Well done out there. The Dinan main channel then, that 20, so that's from Listen to Function out towards Ballyrafton. It's at moderate. It has stayed at moderate, so it hasn't changed. We're trying to get it to good. The Muckalee, around the Muckalee area, Clockpook, Wyfield, in around that area, that's at good. But this is a high status water body objective, so we're trying to get it from good to high. So again, the pressure out here is phosphorus. Forestry is a pressure as well out in this general direction. So we've been working with farmers to try and put systems in place there. The Dushk 20. The Dushk is in and around Gregnamana. It was at moderate. It has stayed at moderate. Okay, so no change. The Powerstown was at moderate, but actually recently I've looked into the science more recently, and this one, it said it was at moderate, but it has improved. So look, it's going in the right track. Again, in the Powerstown, phosphorus is a pressure. Okay, drinking point access is a pressure just down there. Lisdowney, again, phosphorus, phosphate being a pressure around this area, has stayed at moderate, no change. The Nowena, this is a big win, a nitrate sensitive catchment. So look, it's nitrate will be the big pressure out there. And you know, you have a lot of intense dairy area out there, and it has improved. So the systems that have been put in place there are working. So well done. We need to get it to good, and that is achievable. And then the 20, the Nowena 20, that's from Freshford out to Barna. So sorry, the 10 will be around Clumata to Cold Harbour. And then the Nowena 20 then is Freshford out towards Barna. It's at poor and it hasn't changed. And in around the town, we have wastewater treatment plant given a bit of grief, and we also have heavy clay soil. So we need to put systems in place there to try and get that up from moderate up to good, which is achievable. And the next slide, Mark, please. So this is just a picture of, say, around the Kings River out beside where I live myself, out in Dunnamagan, out towards Callan. So on catchments.ie, it's a really, really good resource. You can see, you know, where the pressures are, what water bodies are at good status. So green is good. So this water body up here is green, it's at good. Okay, red around the Kings 50 here is at bad status. It's probably one of the only water bodies, one of 4 nationally, that's at bad. Okay, then orange is at poor, so the Carlesque in or around there is at poor, and then the yellow is at moderate, so that's in or around the Glory here, the Glory 10. So this facility is available, and when you actually touch on the water body, it brings up the data, the monitoring data for that specific area. So you can get an idea of the trends, the nitrate, the phosphate trends, the ecology, the biology. Some of them are up to 2018, and some of them are up until 2021, like the PAAs that we are actually working in at the moment. So look, we have good work done. We've still got a lot more work to do, but some of us are heading in the right direction anyway. So thanks very much for listening tonight.
Okay, thanks, Deirdre. There'll be a few questions into that. I just maybe ask you for just one comment at the moment, Deirdre. you mentioned there about some of the improvements that have taken place on kind of towns or village sewage systems, and that oftentimes farmers will ask, what's the where does the sort of where's the breakdown be, or the breakup, if you take what's problems caused by agriculture and problems caused by maybe sewage plants that are not up to speed, where do we sort of
Well, that's
take
where they
that
have
decision?
to, yeah. Well, so basically, when the scientists go into a catchment first, they'd have a good idea if the wastewater treatment plant is actually up to spec. So they have to be licensed and they have to be checked. And where they're not, sewage, etc., is going into water bodies, or some of it is escaping. So the BOD, you mentioned BOD level earlier. So the BOD of sewage will be somewhere in around the 300 mark, whereas the likes of slurry would be more like it's up near 10,000. Animal excretia will be a little bit more than the sewage, so they have to eliminate that first. So those areas, the wastewater treatment plants, they'd have to be fixed first. Then they go out, they do the science, they walk the water bodies as well. So they look at the ecology, they look at the biology, the invertebrates within the area to denote whether it's at good or poor status. So they look at the Q test. And then by process of elimination, then I suppose they'd, be able to, once the wastewater treatment plants are sorted, what else pressure is there? So there's loads of pressures as well within a catchment, like forestry is a pressure, septic tanks are a pressure. They're quite a big pressure on some water bodies. Quarries, roadways adjacent to water bodies as well. Roads, national roads can be a pressure as well, because particulate sticks to those as well, and that can end up in water bodies too. So, there's a whole load of different scenarios that have to be worked through by the scientist and the scientist team. And a number of people are monitoring. You've got, say, operational or surveillance bridges that look at the chemistry data at a given time, either 5 times or 12 times during the year. And then you have SSIS, as they're called. So they look at the invertebrates in the water body, and they're the best long-term indicators of water quality as well. So there's a whole load of different tests and scenarios that have to be done to eliminate what is exactly the pinch point, or what is the crux of the pressure within a water body. It's not always finger pointing at the farmers.
Okay. No, that's good. No, that's grand. Thanks, Deirdre. Yeah, we'll bring you back into the questions and answers section. Okay, so I'm just going to go on. I have 2 examples here of 2 farmyards that Mark is going to bring up there now. We're just going to look at 2 options that are there regarding and to see what plans can be taken there in terms of improving the storage capacity on both farms. So just the first farm that I'm taking there is a notional farm. So just to describe it there, so if it's a typical cubicle layout with all under the one roof, with a milking parlour and a drafting area beside it. Mark can probably show that there, and just with the cursor there. So the cows they're eating on the slatted area, on the covered area, on the slats there for milking purposes. They go through the parlour. We have a calving area right beside it for calving time. Come back around through the drafter then for and return onto the slats there and back to the cubicles. So that's the situation at the moment. Now, if we take it, Pat has gone through the 2 scenarios there. So with the increased requirement there for storage with the parlor washings and so on, what's the steps? What's the 2 options that are there in order to increase overall storage? So if we just go on there, that's just looking at the shed from a different perspective, so you can understand where it is there: dairy, parlour, calving area, drafting area, and cubicles, and with the feed area on the slats in front. So we have 2 options there. So the first one there is maybe to put in a designated soil water tank to the left hand side there, adjacent to the parlour, to catch all the washings from the parlour area, and that's what a tank will end up looking like there outside of the existing shed. So that's option 1. That would make us compliant. Option 2 then is maybe to put an extra slatted tank, uncovered tank on one side here. The shed will allow us to do that, and And so that'll, as well as increasing slurry storage, it will also give increased feed space for the animals. So, you know, these are the kind of things that you have to weigh up when you're considering, are you going to put in a lot of extra storage on the basis that the soil water or that the parlour washings are being stored with the slurry? And does that give you advantages? And, you know, some people will also argue that when it comes to agitation and spreading slurry, it's advantageous to have it quite liquidy, and that the mixture of the parlour washings and so on with the slurry improves that. But you have to factor in the costs of the tank. So in this case, then, if we go on to the next slide, Mark, we've just put approximate costings on the two options. So option one there was to build a purpose-built soil water tank adjacent to the milking parlour area there, and based on cost this year and exclusive of VAT, we're ending up with a tank of about 9 meters long, 14-foot 6 flat, and 9 feet deep, costing there somewhere between 22 and 23,000, 22,800 and something there. So that's the cost there. If we go for the extra tank on the outside of the shed, so we end up with about a 20 meter long tank, and it has given us the advantage though of the extra feed space and so on. So the overall cost there is just over 38,000 exclusive of that. So this is what you have to try and weigh up here, which is going to give you the biggest advantage. So we'd say 23,000 versus 39,000. You know, almost twice, but you are getting probably more bang for your buck in terms of increased feed space and so on. You know, Pat, when he was doing the calculations there on the extra storage that's required when you're combining it with the slurry, you're talking about probably about 2.5 times what's if compared to a designated soil water tank. Here, the costings are just under twice. So you can this is the kind of calculation that you have to do to see what's the best option for your own situation. So that's that one tank one farm yard that we looked at there. The next one that we're just going to show you there now, that Mark will bring up, is based on a client of my own that just has to make a few decisions too regarding what he's going to invest in. Yeah, okay. So just to Mark will use the cursor again, just to give you an outline of what the current situation is here. So we have then the milking parlour there, more or less in the centre of the yard. So that has been upgraded in a new milking setup in the last couple of years. So that's top of the range. Now we have to consider what's going to be done and cow numbers have increased as well. So we have to consider what we're going to do in terms of slurry storage. Now at the moment, the cows are coming in there. There's two ways of coming into the yard. From one of the roadways, they come in there where Mark has the cursor, come into the collecting yard, come down through the existing cubicle shed, onto the slatted tank here where the cows also eat, up into the other collecting yard, into the parlour, and then they exit then down where the exit is there, back through another older cubicle shed and back onto the slats and out, or back into the shed, whatever the case may be. So that's what's happening at the moment. Also from another part in the farm, the cows just come straight in onto tank A from the bottom and go up through the parlour, depending on depending on the time of the year and where they're grazing. So now the sort of the options, what's going to happen here. One of the first things that we've kind of decided here, maybe that should happen, is that where the collecting yard, which was there, if you might remember, up at the top there beside where Mark has the cursor there, that is, we're going to try and eliminate that collecting yard. It's on quite a slope there, and it's obviously an unroofed area. So if we could eliminate that, that will increase or decrease our storage requirement considerably. And the possibility is that we can extend up the existing shed so we can put cubicles and so on in that area and in the future. So by doing, if we do that, then in order to come up with extra storage, one possibility is the tank that you can see down at the bottom. So a new tank D down at the bottom, which is about a 20-meter long uncovered tank. Tank A is an uncovered tank as well. That's one possibility. It will increase the storage considerably, and it will take account of the soil water that's being generated. So again, the soil water parlour washings is going to be stored with the slurry. So our storage has to match that bigger demand for storage. It's probably not the totally ideal situation, but probably one of the lowest costs that we can come up with. And there's a possibility of linking the two tanks together with a feed passage in the center to allow the cows to come out from the existing cubicle sheds to eat and then increase our feed space, or the feed space allocated to the cows and so on. So that's one option. And I suppose what we're trying to work out here is that whatever you do regarding maybe tanks you're going to build, is it going to improve cow flow, and is it going to make life easier for you in the long term? So there could be a few options on any farm. Now, one of the things that we're just considering here, from the last slide there, you would remember that there was a silage pit there in the middle. And oftentimes with silage pits, they come to their end of life situation where they get worn out, and maybe the time is to, maybe that would be an opportunity there to take out the silage base, put it elsewhere, or go to making all bale silage with all the downside associated with that. But to change that area then into, you could put a new tank in there and a feed passage and so on, and get our slurry storage right there. And we'll have where the old collecting yard was, we've extended the cubicles up into it. So that's giving us extra cubicle space there. And then where the other cubicle shed was, which is sort of, I suppose this stage, maybe a bit on the old in terms of low roof and so on, that could be eliminated. And we get a better, cleaner drafting area coming out from the parlour. So that's probably if we sort of from a long-term viewpoint of view, that's probably the most desirable solution to come up with, and not putting the tank D that we had there underneath tank A, but there is considerable expense involved in that. Now, I suppose the reason I'm putting that example in front of you is just to get you to, whatever situation you have yourselves, consider the options that are there, and how any investment that you make now, how it will improve cow flow and improve labor efficiency on the farm. So that's a farm that's on the ground, and where the farmer concerned is considering what he's going to do next in terms of getting over the requirement for extra storage. So that's the two example farms that we have there. So that's the extent of what we want to put in front of you tonight. So we're going to move on, I think, to the questions and answer section, and I'll ask everybody maybe or all our contributors, just maybe to come back in terms of unmuting yourselves. There's a few questions in there, Mark, are there?
Yeah, there's a couple there, Michael. Yeah, the first one there is that if after yards have been washed down, can you then divert the rainfall that falls on this clean yard to an open drain or a soakaway, and then discount some of the rainfall that was in the figures that Pat had earlier? Maybe Pat, okay. First of all, I suppose.
Yeah, look, I hear what they're kind of trying to achieve, but I suppose in the day, cows are going to milk morning and evening. Are you going to spend as much wash water trying to clean the yards as possibly might happen in rainfall over the period? I think the big thing I see there in what the drawing I produced there is that if we have cows coming out through a drafting facility and through a narrower channel, which has, the slurry channel underneath, we can, apart from AI times, which is well finished now, that holding yard in the middle, by and large, can be a clean yard and never get dirty, actually. So we're trying to minimize the area that's dirty. I don't know, is it feasible to be washing the amount of water that you use morning and evening to wash the yard to make them a clean yard? Because at the end of the day, I suppose, look, that could negate what you're trying to eliminate. But at the end of the day, the yards are there, they're draining towards the tank. If yards are clean, and that even goes for the front of a silage pit, don't forget, in all these other areas. If yards are clean, well, then that water is not soil water. It may be a term we call grey water, but it's definitely not soil water. So management has a big part to play. And as I think I said at the outset, the first step I would take is to look at the whole cow flow, as Michael gave a good example there, what we can do for you on a farm visit. And now it's very easy to do drawings using Google Maps, etc., to get an idea of how a third party or person might come into the yard and see how can the cow flow be improved and reduce the area that is liable to be soiled. Because if once it's soiled, you have no option only to collect it. It cannot be let off run off the yard.
I suppose the other end of it as well is if so like roof water is clean water, it can be diverted straight into a drain. Okay. If rainwater falls on a silage slab base over the winter period, if there's any particulate on it, any or effluent on it at all, that shouldn't be diverted. It has to be contained. It's the soiled water. Okay, even we tested one above in the Brega recently, and even though there was no silage on it at all, the BOD level of it was 1,000. So that couldn't have been allowed straight into any water course or any drain. It would have had to have been collected. So clean yards, they can, if there's no particulate nitrogen or phosphorus on them, they can go to a soak away, as is in the chat, or they can be into a buffer zone as well. They can be cleaned, but they can't be released directly into a water course or into a river. Yeah.
I think the point you made there, Deirdre, as well, and I see a lot of yards, the amount of roof water that unfortunately in some yards is falling onto dirty soiled yards, downpipes missing, chutes not connecting up. So
Yeah,
look,
it's a massive contributor to the soil water anomaly,
as
definitely.
said to me, it's important to look up as well as looking down. Maybe sometimes we just look down on what we're under our feet, but look up and see where is the water being collected. I see the second question there, just when I'm on there, is about that Excel calculator. So I can't put up the link here tonight, but it will be available through email if you contact your dairy advisor in the Kilkenny, Mullavat or Dungarvan offices. And I also have, suppose, a further expanded calculator where you can actually put in the dimensions of all your tanks on the farm, covered and uncovered, and you get the net storage balance at the end of the page. So that's available through your local dairy advisor in either Kilkenny, Mullavat or Dungarvan.
Thanks, Pat. There's more questions coming in there, Mark. Do you want to call it?
Yeah. Just a question on buffer zones there, I suppose, maybe, Deirdre, from a spreading of soil water point of view, is there buffer zones applicable there?
There's buffer zones, like they're gone from, they're 5 meters for slurry and soil water and 10 meters at the, at the shoulders of the ear. A buffer, I suppose, what is a buffer? So a buffer is an area where nutrient can be attenuated. So like within a 2-meter buffer even, there was an experiment done in 1979, and most nutrients can be attenuated if it's flat ground within a 2 or a 3-meter buffer. So that's grass. So it attenuates all the nutrients. It uses them up. It acts as a blockage between the water course and the nutrient. So that's what a buffer is there to do. So, and they're very, very important to be kept. So a 5-meter buffer for the slurry and the soil water, and a 10-meter buffer then at the shoulders of the ear is very, very important.
Okay. Just one other one there then, that we had a lot of very heavy rainfall events there over the last month or 6 weeks. Is there any allowance there for spreading soil water where tanks have got filled up with a lot more rainfall than there would be normally?
Okay, so maybe I'll take that one. I mean, just going on the minister's announcement there, it was after Storm Babette. I think that these names are there's so many names floating around, but there was a number of tanks after that severe storm, tanks that were kind of empty and they got filled up with water, and but they were essentially empty tanks. Now what he allowed there was that those tanks could be sucked out, the water could be sucked out and spread, no use of an agitator, and that was permitted. But a situation where you have tanks at the moment that are filling up and maybe filling up with parlour washings and so on, it's not permitted to just suck water out of those, because essentially what you have there is soil water that is mixed with slurry. It's deemed to be slurry. If you do the test on it, it's going to fail the soil water test. So it's not permitted to go out with that.
There's a question there on the buffer. So if you're talking about particulate nitrogen and phosphorus, so chemical fertilizer, there's a 3-meter buffer within grassland areas for that.
Okay. Another one coming in there. If cows are standing on a starter tank while being milked, presumably in a collection yard tank in this case, for up to 5 hours daily, is the water in this tank soil water or is it slurry?
Look, for me there, I suppose the simple answer is it can be both. It's all down to the dilution rate. As I said earlier, if cows are standing and being fed on the tank, then it's definitely slurry, not soil water. But the ultimate answer I put out to that question there is you can get your slurry or soil water tanks analysed, and if the dry matter is below 1%, it's soil water. and it's above 1%, it's slurry, and that's the ultimate. And a number of years ago, and it's a good practice for farmers there, a couple of discussion groups in Kilkenny and Waterford did get splatter tanks, covered and uncovered, and collection yard tanks analysed. And then you have your actual analysis in the event of someone coming on your door and wondering what's going on out in the fields. So I can't say yes or no to that question really, because it's down to the size of the tank, it's down to how much rainfall or water yard area is contributing to it. To dilute is below 1% dry matter. But you know, definitely where animals are being fed on a tank, buffer feeding, that is slurry, full stop. But the analysis is the answer for the cost of maybe 60 to 70 euro. You take a 2-litre sample of the material and you get down to FEA laboratories or IAS in Bagnallstown and get it analysed, and you will get the NP and K value and the dry matter. And it might be something you could do for a little winter project, or indeed with your discussion group, and try and use it as a way of reducing fertiliser usage in 2024. Very worthwhile doing for sake of 60 to 80 euro.
Probably the situation has been described there, Pat, where you just say the cows are standing for a long period, you know, on the collecting yard. All that is going to increase the chances of more slurry going into the tank, and just the value is going the wrong way regarding soil water. So it could be due to just you know, just a lot of time spent milking or whatever, depending on a given situation. So that's the only comment I'd make on that. Still another one or two questions there, Mark.
Yeah.
Is there?
Just did the panel think that soil water will have to be spread with low emissions spreader in the future, the way it's gone with slurry?
Yeah, I think like from what we're seeing for the moment, there doesn't seem to be anything there saying that it has to be spread with low emission. What is there in the statutory instrument is that it should be, if it's done with a splash bed, make sure that it's pointing downwards. There doesn't seem to be any prohibition on that if it's a soil water situation. Yeah. Now, I suppose but we've seen, you know, most people at this stage, given the last few years, have seen the advantage of spreading slurry and so on with low emission systems, and I think there's been a general buy-in for that. And it, you know, it should be the same thing with like soil water is very easy to put out and with that situation. So I think that's probably the way we're going on that one. Yeah.
And the main objective by using less is to reduce ammonia emissions. So typically the nitrogen content of soil water is around 2 units per 1,000 gallons, whereas with slurry it's up maybe 9, maybe up to 12, depending on time of spreading. So the lower the nitrogen content, obviously the lower the risk of higher ammonia emissions. So as Michael said there, at the moment it's not by less, it can be by splash rate, but for most people they have the less equipment at this stage, so they're going to use it for both jobs.
Okay, and just one for Deirdre then, I'd say, are there details available on rivers in Waterford like you had for the ones in Kilkenny there?
Yeah, no, absolutely. And if that person wants to get in contact with me, they ring the Kilkenny office, or they can ring the Mullinavat office and talk to Cahill himself. Yeah, absolutely, that information is available. I concentrated, I suppose, on Kilkenny tonight because that's where I'm actually working. But there's great work being done in Waterford as well. Fantastic work being done in Waterford, and that information is available. Also, back to the buffers. Like, the buffers are a fantastic mode to protect the water bodies. And I suppose just to add to that as well, they're an area within which no chemical fertilizer or organic fertilizer can be spread. I suppose that's another part of the definition for it. But they're a very, very important part of our job. And I suppose if they were kept, you know, we'd have a great opportunity to remediate a lot of the water quality pressures in both Waterford and Kilkenny. So just keeping those buffers is extremely important.
You mentioned there, Deirdre, about the weather doubled for the first 2 weeks of the last 2 weeks of the slurry spreading season, and the first 2 weeks. So I suppose if we take slurry spreading starting around the middle of January, so you know, up to the end of January, those buffers are in place. So, and that, you know, there tends to be a fair movement of slurry at that stage. But the importance of that in terms of adhering to the extra buffers, yeah.
Yeah, no, absolutely. I suppose we, you know, during some of the acres courses that we were doing recently, you know, we were measuring out those buffers with farmers, and they're quite big buffers, you know, when you actually look at it. So I suppose there's an education needed with the buffers with some farmers and also contractors as well, you know, going forward.
Have we another
Yeah,
one there,
there's
Mark?
one final one there about, yeah, it's about the River Clodagh in North Waterford.
Okay.
And what's the pollution contributor there, but we'd probably need Cathal on the line.
What
to
is the biggest
answer
pollution
that one.
contributor, farming or non-farming, runoff from cultivation or forestry? Pascal, I can't answer you that now straight up, but again, if you leave your details, I'll get called to get in contact with you at that. I don't have the specifics of Waterford with me at the moment.
Okay.
Okay, that's about it from the
What kind of
questions, I think,
commentary? Yeah.
Michael.
Yeah, we're doing pretty well there. We're just on an hour on, so that's not too bad. I mean, I suppose just to summarize, I think we've covered a fair bit of ground there. I've tried to give you just an overview of the, you know, where the soil water thing is coming from and where we're heading towards next year. Pat has done some calculations there showing you the difference between whether you go for the 1 month storage approach or whether you combine it with slurry. I've given you the two examples there for the two farms concerned, just of what the solutions might be, and just putting some figures on it too. It's always worthwhile looking at the costs that are involved, especially the way costs have gone in general on building, which is pretty serious increase in the last while. And then Deirdre's giving you the overall view there regarding the water quality. I mean, the one thing that we'd say the big debates that have taken place in the last few months regarding the future of derogation and stocking rates and so on, the one thing that will stand to agriculture in the future is if we can improve water quality. And Deirdre has shown there, you know, where this has improved in some areas, and that doesn't happen by accident. That happens by improved practices in those areas. And that's the one thing that will stand to agriculture in the future. So you can just see that these things rivers are not static; that they are changing, and obviously that it's the improvements that we're looking for, and just to understand where these improvements come from, the changes in practice. So I think we'll leave it at that. We say thanks, Ryan. There's over 70 people on there tonight, so. The follow-up you can do with ourselves and with the people in the other offices. Just as it happens tonight, we're all here from the Kilkenny office, but just as
And Michael, just to mention before we finish up there, that this debate will be continued next Wednesday at the National Dairy Conference, which is on in the Lyrat. There are 6 farmer workshops in the afternoon. One of those is all about soil, water and slurry storage, and a good program of events for next Wednesday, the 29th of November in the Lyrat. You've got plenty emails and texts about it. 2 farmers from local level in the morning, and then in the afternoon you pick 3 out of 6 workshops, and one of those workshops is all about soil water. So that would be maybe a good layout in Kilkenny in the Lyrat, and please book in now. Just when you mentioned that, Michael, before we wrap up.
Yeah, that's okay, Pat. Yeah, good. No, that's good. Okay, so thanks.
One other thing, sorry, Michael,
Mark,
before we go, just to point out, the recording of the webinar will be available there on the Kilkenny Waterford Teagasc YouTube channel in the next few days for anyone that wants to have a look again.
Okay, and thanks to Mark for his IT backup there. Okay, so we'll finish up with that, and thanks for everybody for coming on.